All right, this is the video solution guide to the third page of your nomenclature packet. Today, this introduced polyatomic ions. So you have, it's still ionic, meaning you're going to have either a representative metal or you may have a transition metal with various charges, but the thing is that you will have some kind of polyatomic ion on there, these elements that have two or more elements bonded together that have a charge. All right, so this first one, you'll notice you have cobalt, which is a transition metal, so we're going to have to determine what its charge is. And so just like before, we're going to unzip these guys. So we're going to put cobalt over there, and then this whole thing is a functional group. That is a polyatomic ion. Okay, that happens to be nitrate. So that thing goes over there. Just like before, this charge, or that subscript, becomes the charge of the nonmetal, and then this one becomes the charge of the metal. Then, just as before, you have to look at nitrate and make certain that its charge matches what it should be, because they have fixed charges. Nitrate is 1 minus. That means cobalt is 2 plus. So we're going to name this thing cobalt, Roman numeral 2, nitrate. Okay, this next one, notice you have sodium, which is representative, so we don't have to unzip this one. We can just name it. And so sodium, and then you look up on your table, NO2. NO2 is nitrite. So you got to be very careful because, this previous one was NO3 is nitrate, NO2 is nitrite. So you have that table, look at them. Make certain you're verifying the names and the formulas of all the polyatomics. There are some that are very similar. Okay, here we have copper, and copper does have more than one charge, so we're going to have to unzip this guy. Put copper here, and then that PO3 is one thing. Okay, this number 3 goes up above here. This number 2 goes over here. And so PO3 is phosphate. Its charge is 3 minus. So we're going to name this copper, and then its charge is 2, phosphite. BaCN2. So Ba, that's barium. It's always 2 plus, so I just named this guy. Barium, and then CN2 is cyanide. So that is one of the two that the polyatomics, usually they end with 8 or 8. Cyanide, ends with IDE like an element. There were a couple of them like hydroxide, cyanide. You just have to remember that. All right, aluminum is representative, so we can just name this because it's always 3 plus. So we just name them aluminum. And then SO4 is sulfate. You don't have to mention any of the numbers because that's the only way aluminum and sulfate combine. It's in that 2 to 3 ratio. KClO3, K is potassium. It always has a charge of 1 plus, so we simply name this one. Potassium, and then ClO3 is chlorate. Potassium chlorate. Okay, in this instance here we have copper. Copper has more than one charge, so we've got to unzip this guy. Now the thing you have to, this is where people will sometimes make errors. This too is part of that formula for that polyatomic. If you're going to be moving something like this too, does not go over there. That doesn't work, all right? You can't do that. If you're moving a subscript from behind a polyatomic, it's got to be outside of parentheses. All right, I'll show you here in a second what the other thing would look like. So that 2 is part of C2H3O2. That's part of a polyatomic called acetate. There's a 1 here that goes up here, which is the charge of acetate, and then there's an understood 1 here because there's no parentheses, but if there was, there's an understood 1 here. There's 1 acetate, and it would go here. So this is copper 1 acetate. Now, if some of you thought that maybe, okay, that that maybe that should be copper 2. This is what copper 2, so that's copper 1 acetate is that answer. If you were trying to do copper 2, it would actually look like this. So let's do it the opposite way here. If I said copper, and I said Roman numeral 2 acetate, this is what it would look like. That 2 would imply that copper's charge is 2 plus. Acetate is C2H3O2. It's 1 minus. And so what this 2 would do, it would come down here on the end, and to prevent it from looking like 22, you'd slap acetate into parentheses. So, yeah, this is not copper 2 because, yeah, this 2 doesn't move as part of acetate. So hopefully that makes sense. Okay. This guy, francium. Francium is representative. It only has a charge of 1 plus, so we simply name this francium. And this is dichromate. This has that polyatomic cation. So that means the first one, the positive ion. That guy is on the table on your periodic table. It's the second one down on the left-hand side. That is ammonium. And it has a fixed charge, so we're just going to name this ammonium chloride. All right, this one we've got lead. Notice lead down there, number 82, has more than one charge. We've got to unzip this guy. Lead goes here. This 4 is part of SO4. It's a polyatomic sulfate. There's a 1 here that goes up to sulfate. There's an understood 1 here that goes up to lead. Well, first thing you'll notice, lead doesn't have a 1 charge. Lead's either 2 or 4. And then you're like, oh, sulfate isn't 1 minus. Sulfate is 2 minus. If you double one, you double them both. This is lead 2 sulfate. It has to be lead 2. And here's another way of thinking about it. So there's lead 2 sulfate. If you think about it from the formula part, if lead's charge is 2 plus and sulfate is 2 minus, if they're equal and opposite, they reduce or cancel or simplify. PbSO4. So lead 2 sulfate. Barium. There's barium. It is a representative element. It has a charge always of 2 plus, so we just name this barium, and then OH is hydroxide. KClO. Okay, once again, potassium is always 1 plus, so we're just going to name this potassium. And then ClO is hypochlorite. It's a polyatomic. So potassium hypochlorite. All right, so now we're writing some formulas. Rhodium 2 chromate. So rhodium 2, that tells me rhodium's charge is 2 plus. That's what that Roman numeral tells me. It is the charge of the metal. Okay, it's not telling me how many rhodiums. It's not telling me how many chromates. It's simply the charge of the metal. Chromate is CrO4, and its charge is 2 minus. Notice they're equal and opposite, so they cancel. That 4 doesn't move because it's part of chromate's formula, RHCrO4. Lithium hydroxide. Lithium is always 1 plus. Hydroxide is always 1 minus. If you have 1 plus and 1 minus, they cancel. LiOH, lithium hydroxide. Sodium permanganate. Sodium is always 1 plus. Permanganate is MnO4 and it's 1 minus. Once again, 1 plus and 1 minus, they cancel. NaMnO4. Sodium permanganate. Okay, manganese 3 nitrate. So this tells me that I have manganese, and manganese has a 3 plus charge in this instance. Nitrate, I look up nitrate, it's NO3 and it's 1 minus. So I write my metal, I write my nonmetal. This 3 goes down here. This 1 goes there, the 1 is understood. I have to put parentheses around nitrate so that it doesn't look like I have 33 oxygens. So it's MnNO3 parentheses 3. That is manganese 3. nitrate. Barium nitrite. Barium is always 2+. Nitrite is NO2 and it's 1-. So I'm going to write my barium, I'm going to write my nitrite. This 2 goes over here. This 1 goes here. I need parentheses. Ba NO2 parentheses 2. That is barium nitrite. Aluminum hypochlorite. Aluminum is always 3+. Hypochlorite is ClO and it's 1-. So I'm going to write my metal. I'm going to write my nonmetal. This 3 comes down here. This 1 goes over here. What you guys have to understand that the parentheses have to be in place, okay, because that tells me it's aluminum hypochlorite, because if I don't put it, that is not the same thing as saying AlClO3, because if you write it in this fashion, this doesn't look like hypochlorite anymore. That looks like chlorate, okay? So whenever you are taking a charge and you are placing it behind a polyatomic, you have to put the polyatomic in parentheses, regardless if it has numbers or not. So this is the answer, AlClO parentheses 3. This is aluminum hypochlorite. This is aluminum chlorate, and it's written incorrectly. So, yep, this is how you do it. Potassium phosphate. Potassium is always 1+. Phosphate is PO4 and it's 3-. Put my metal, put my nonmetal. This 1 goes here, this 3 goes here. K3PO4 is potassium phosphate. Copper 1 acetate. This tells me copper's charge is 1+. Acetate is C2H3O2 and it's 1-. Okay. 1+ and 1- equal and opposite. They cancel. Okay, the 2, the 3, and the 2 stay with acetate. That's part of the formula. Ammonium bromide. So we have ammonium, which is the polyatomic cation, NH4 with a 1+. Bromide is always 1-. Equal and opposite cancel. NH4Br. The 4 stays with ammonium. Sodium carbonate. Sodium is always 1+. Carbonate is CO3 and it has a 2- charge. I write my metal. I write my nonmetal. 1 goes here, so you do nothing. The 2 comes here. Na2CO3 is sodium carbonate. Lithium chlorite. Lithium is always 1+. Chlorite is ClO2 and it's 1-. 1+ and 1- equal and opposite. They cancel. The 2 stays with chlorite, LiClO2. And that's it.